Welcome to the fourth video of 8 in a series about polar graphing. Circles. Now, let's take a look at our first circle graph in polar form, not to be confused with the unit circle. Here's the equation of a circle graph as we're going to discover. So, what we'd like to ask ourselves is, how do changes in theta affect the variable r? To do that, we will look at the four quadrants as theta goes from 0 to pi over 2, quadrant 1, as theta goes from pi over 2 to pi, quadrant 2, as theta goes from pi to 3 pi over 2, quadrant 3, and as theta goes from 3 pi over 2 to 2 pi, quadrant 4. Now, if we're going to analyze changes in r throughout the quadrants, it would help us to know the value of r at all of the quadrantal angles, the angles between the quadrants. So, I'm going to plug in these 5 values into my trigonometric function. Each one of these can be worked out using your knowledge of the unit circle, and while they're not shown here in detail, here are the final results of those. So what do these r values tell me? Well, they tell me in quadrant 1, as theta goes from 0 to pi over 2, r is going to shrink from 5 down to 0. I'll put that here. As theta goes from pi over 2 to pi, in quadrant 2, r is going to shrink further from 0 to negative 5. In quadrant 3, r goes from negative 5 to 0, and in quadrant 4, r grows again from 0 to 5. And this analysis of what's happening to r for different changes in theta will help me answer the question, how are these changes displayed in the polar graph of this equation? Let's start by having theta sweep through quadrant 1. You'll notice in the table in the upper right corner that r is going to shrink from 5 down to 0. So here's r shrinking from 5 down to 0 in quadrant 1. Now, as we sweep through quadrant 2, notice the table indicates that r is going to go from 0 to negative 5, meaning r is going to be negative throughout quadrant 2. But that means the points will be behind quadrant 2 in quadrant 4. Here's r going from 0 to negative 5 throughout quadrant 2. Now, once we're done going through quadrant 2, it's time to go through quadrant 3. Something a little different happens here. Notice as theta sweeps through quadrant 3, the table indicates that r is going to go from negative 5 to 0. Well, here's r going from negative 5 to 0 as theta swept through quadrant 3. But that just traced over the same points we already had, adding no information to the graph, which is fine. And finally, as theta sweeps through quadrant 4, our table indicates that r is going to go from 0 to 5. Again, when r goes from 0 to 5, we're tracing over some of the same points we already had. And so, unusually in this problem, if we had only graphed from theta equals 0 to theta equals pi, we would have had the whole graph anyways. No harm in going too far, it just gave us confirmation that the circle was where we see it to be. Here's another example. This also turns out to be a circle. And we'll ask the same question, sweeping through the 4 quadrants, what happens to r? We'll find our quadrantal points here. Plugging in these 5 values into the equation, using your knowledge of the unit circle would ultimately give you these. Again, I didn't show the work. We'll do the same thing with constructing a chart of what's happening to r in each of the quadrants, just like before. And now it's time to ask, what do these changes in r do to the graph? Watch as theta sweeps through quadrant 1. Now, according to our table, as theta sweeps through quadrant 1, r is going to decrease from 0 to -4, meaning it's going to be negative the whole time. That means that the points on the graph will be behind quadrant 1, in other words, in quadrant 3. So watch as we sweep through quadrant 1 and r goes from 0 to -4. Now we're through quadrant 1, on to quadrant 2. In quadrant 2, our table indicates that r is going to go from -4 to 0. Still, all negative r values. Therefore, behind quadrant 2, the points are going to show up in quadrant 4. Here's theta sweeping through quadrant 2 and r going from -4 to 0. And just as in the last problem, this is the entire graph, because as we allow theta to sweep through quadrants 3 and 4, we will get a retracing of the points. But I'll show you anyways. Here's theta sweeping through quadrant 3. Notice the table indicates that r will go from 0 to 4. There's r going from 0 to +4. And finally, in quadrant 4, watch as r goes from 4 back to 0. Okay, you've just seen 2 examples of the graphing of a circle. Let me make some general observations that I have. Now, I'm going to share some things I've noticed over the decades. These are not things that you're expected to know, but they're just observations from my perspective. Whenever we have an equation in this format, either of these 4 formats, we end up with a circle tangent to one of the axes passing through the origin. So these are the generalizations I've noticed after doing many such problems. If we have an equation, positive number times cosine theta, it's going to be a circle through the origin tangent to the y-axis. If we have negative number times cosine theta, it's going to be on the opposite side. I've also noticed that if we have a positive number times sine of theta, it's going to be a circle through the origin tangent to the x-axis. And in all of these cases, d is the diameter of the circle. And if we have a negative number times the sine of theta, the circle will be down here. And while some students have a tendency to want to memorize those as facts, the only value I can really see in them is if you were in a course where you were taking a test and you had no technology and you just wanted to memorize those facts to get you through some kind of a testing situation. But aside from that, there's sort of a danger in memorizing facts like that, for two reasons. One, facts will disappear over time and out of your brain. And more importantly, the goal of polar graphing is not the final answer. It's the thought process that goes into it. If all we want is a final answer, we have technology for that. But the process of analyzing what happens to one variable while there are changes in another variable, that's the process that I use on this problem. And that's the process that scientists and engineers use all the time. And that's the kind of thinking that we need to develop. So again, if getting the final answer is your goal, that's one thing. If learning how to think is your goal, this is the way to do it. Because if you go through this process, you can not only graph circles, you don't have to remember when something's going to be a circle, it will just show up to be, and you can really extend this idea to any polar function and not have to memorize a bunch of seemingly useless information. And that completes the 4th of 8 lessons.